In my first video, I provided an overview and brief demonstration of my Rose engine lathe that I built in my workshop about 6 months ago. The Rose engine is used to create circular guilloche engraving patterns, and that's really only one half of the puzzle when it comes to guilloche engine turning work. So it works fantastically for creating circular patterns and bordering. The issues that the Rose engine runs into is when you get closer to the center of your workpiece, your amplitude stays the same and it becomes really busy and hard to read the pattern. So what I am planning on doing is I'm building a straight line engine. So just as the Rose engine creates circular patterns, the straight line engine is used to create linear patterns. There are a couple ways to achieve linear guilloche engine turning pattern work. You can actually do a conversion on your Rose engine to translate the circular motion into linear motion and still use your rosettes for pattern work, and those work fantastically. However, for workflow in my workshop, I really want to have two separate machines. So the standalone Rose engine and a standalone straight line engine. I'll be coming up with some quick change chuck systems where I'll be able to swap dials and other parts that I'm working on between the two machines relatively easily and precisely. The Rose engine is great at circular patterns, however the patterns become really hard to read as you get closer to the center. So the plan is to use the Rose engine to create decorative bordering and pattern work on the outside of the dial, so the outer edges of the dial, and as it works towards the center, I'll be swapping over to the straight line engine to create linear patterns in the center. So the linear patterns don't suffer from the same distortion that the circular patterns do as you're working in a circumference and working your way towards the center of a circle. So the linear patterns stay consistent no matter how wide you're creating the patterns or how tall the patterns are. This video is really just a brief introduction into my straight line engine build. I have some parts on my bench here that I've accumulated over the past couple of months. Some parts were on back order that just showed up a couple days ago, so I'm excited to have those in my possession. So I'm just gonna go through a brief overview of each of the parts that I've collected so far. I'll talk about where I got them, how much I spent on them, the downfalls of some of the parts that I have, some modifications that I'll be making, and some custom parts that I'll be making. This process is going to require quite a bit of machining and quite a bit of fabricating on my end. So I'll be welding a tubular steel base just like I did with the Rose engine. I'll also be machining some dovetails for some linear motion and creating some parts that I just couldn't buy off the shelf. So I have my parts roughly laid out in the orientation that they will be on the finished machine. So I have my cross slide table, and it functions exactly like it would on the Rose engine. So it's used to advance my cutter from left to right in whatever progression I need to match the pattern that I'm working on. This cross slide table I picked up off of eBay. It is imported Chinese or Taiwanese unit. It was pretty rough when I picked it up. So all of the dovetail joints are just really roughly fly cut. So I pulled the whole machine apart. I stoned all of the ways to get them to move smoothly. I cleaned up the gibs and reset all the gib adjustment to tighten everything up. I tightened up the thrust bearings on the lead screws and just oiled everything up. So the table castings are actually pretty good. I stoned the surface flat and ran an indicator across it, and it's actually pretty flat, and it moves very smoothly. It has very large diameter trapezoidal lead screws, which the Grizzly unit that I have on the Rose engine does not have. So it actually moves quite a bit smoother than the other unit I have on the Rose engine. So I really like it. Another huge advantage to this, particularly when working with the straight line engine, is there's no shelf on the back. So after the edge, so in the Y direction, when I have the table pushed about halfway across its travel, there is no edge here, so it just drops straight off from the face. And the advantage of that is I can have my cutter mounted in the middle of the table here, and my straight line engine will be feeding the workpiece down linearly. So it'll feed past the edge of the table, and if it was sticking out like it does on the cross slide that I have set up on the Rose engine, it would hit the workpiece. So it just drops straight off. There's no screws, there's nothing sticking out the back, which is fantastic, and it works really well for what I need it for. The Y-axis feed handle is kind of in the way, and there's a whole lot of backlash in it, and I really don't need consistent Y feed. So my feed will be done on a dovetail cutter that I'm going to be machining. And so I'll be feeding into the work by hand, just like on the Rose engine. So I don't really need this handle here all the time. So I'm going to take the handle off and just put a couple jam nuts on there, and I can adjust it with a wrench if I do need to adjust my Y direction feed in. It'd actually be kind of helpful to set 0 on a new workpiece. So I don't need this handle, I'm going to ditch that. The gradations on the handles are cast into place, and they're really bad. And there's actually no counter mark on the casting that holds the bearing to actually even read the gradations on the dial. So the dial is useless and the handle is pretty poorly cast. So I'm going to be installing a digital readout scale just like I have on the Rose engine. I'll be installing it on the front face here, so I'm going to have to come up with some creative mounting positions for that. But I'll just be relying on the digital readout to advance my cross slide in the X direction. Otherwise, the casting is going to work out really well. It was $100 off eBay, so it'll work really well for what I need it for. So that was a good score. On the left-hand side here, I just have a cast iron blank. It's just a hand wheel blank that I picked up off MSC. I think this is 10 inches in diameter. I can double check that. Yeah, it is 10 inches in diameter. And it doesn't have a bore cut through it. It doesn't have the handle hole drilled and tapped, so I'll need to do all of that, but I can do that on the lathe, and I can just drill and tap that on the mill really easily. So it's 10 inches in diameter, and so this is where I'm going to be getting my mechanical advantage when I'm using the lead screw to move the column head up and down. So if I do need a higher mechanical advantage, I'll probably just pick up a bigger wheel, maybe 12 inch, 14 inch, and so that's really going to give me the power that I need to turn the lead screw and advance my workpiece through the column. This here is just a very small Mitutoyo micrometer head. So just a really small micrometer head. I think the travel is only like a 1/4 inch, something like that. Not a whole lot of travel, but it doesn't need a whole lot of travel. So on the Rose engine, I use a guide to set the depth, and that works really well for a workpiece that might be sort of inconsistent. But on the straight line engine, since I'll be using it after using the Rose engine, I don't want to have the guide in place that might rub over other guilloche work that I've already done. So I'm going to be using this micrometer head as a stop. So I'm going to machine just out of mild steel a cutter feeding system. So it's just going to be matching male and female dovetail with a gib to set adjustment and take out any slack in it. And then I'm going to be mounting this micrometer head as a stop on the moving part. So I'll be able to set it at 0, advance my table in the Y direction until my cutter just touches the workpiece, and then I can feed into whatever depth of cut that I want. And so I'll be using this micrometer head as my stop. So over here, what I have is actually a milling attachment for a lathe. So you would take off your tool posts and you would actually bolt this onto your cross slide, and you would be able to mount or chuck end mills up in your lathe and actually do machining work and milling work on your lathe. And so this is actually going to become my pattern bar holder. So I picked this one particularly because it has 50 thousandths of travel per revolution. So it's a really fine thread lead screw that's in here, which is going to give me really precise adjustment in my pattern bars. So the total travel in the Z direction of my column is actually 9 inches, and this is only a little over 5 inches, I think. So I'm going to be machining a pattern bar holder that'll kind of stand off from here and be able to hold pattern bars that are up to 9 inches long. So the way that this will work is I'll have my pattern bars mounted up, and just like on my Rose engine, I need to be able to phase my pattern bars or my rosettes to create the pattern that I'm looking for. So I'll need to stagger patterns occasionally. A great example would be for basket weave. So you would have a very sharp zigzag pattern on your pattern bar, and you need to offset your cross slide in the X direction a certain amount, and you also need to phase your pattern bar to create the next weave in that basket weave pattern. So I'll be creating my own pattern bars. When I create them, I'll know what the exact distance is between them. And so if I want to phase by 1/4, so let's say that I space the peaks of my basket weave pattern bar out by 10 thousandths of an inch, so a really fine pattern bar, I know that I can move 2.5 thousandths since I have a really fine lead screw. So I can feed down by 2.5 thousandths, make my next cut, move my cross slide over, feed down to 5, then down to 7.5, then down to 10, and then set back to 0 to create that pattern. So it's gonna work really great for that. It's plenty strong, it's all cast iron. I don't think I'm gonna have any deflection issues. Really the only stress that's put on to my pattern bar holder is spring pressure. And so maybe 15 to 30 pounds. I haven't really decided what will work best. So I'll have to do some experimentation, but whatever it is, this will hold up to it. And so this is the lead screw that I'm going to be using to feed the column head up and down. So I picked this up off McMaster Carr, same with the brass nut to match. So this is a 10 thread start, 1 thread per inch. So basically 1 revolution of this brass nut translates to 1 inch of travel in the linear motion. So talking with some straight line engine owners and some operators, they were able to give me some information about how much feed they're getting from their column with 1 revolution of the wheel. And so like I was talking about, the mechanical advantage that it'll get from having a larger hand wheel is actually going to be translating into this. So it's going to have a 1-to-1 motion. So every rotation of my hand wheel is going to rotate this lead screw 1 time. So there's not going to be any gear reduction or gearing up to get a faster speed. So it's just going to be 1 turn. I'm going to need to machine something that this brass nut will thread into that'll actually attach to the column. So that's a part that I'll need to machine. But this is a 3-foot rod, and I'll probably be using nearly all of it. So probably 2.5 feet of this 3-foot threaded rod. So the last couple of pieces to my straight line engine puzzle here that are pre-made parts that I'm repurposing for my straight line engine is going to be this column and column head. And these are repurposed from a Grizzly benchtop milling machine, both cast iron parts. So I was able to buy them pre-made. So it's just off the shelf parts from Grizzly. This column was on back order for a couple of months, so it took a while to come in. Just came in a couple of days ago, so I'm excited to have it here. So I was able to get the parts with the dovetails already cut, with the gib and the gib adjustment screws already in place, and the locking parts. So a whole lot of parts that I'm saving myself from having to machine, and it really only cost me a couple $100 for them. So the way that it's going to work is the lead screw that I was talking about is going to actually feed through the column. So it'll be coming up from the bottom, and then I'm going to machine the lead screw to mount in to the top here. It's going to have a couple of thrust washers and some bearings and a nut to hold it in place on top, and I'm going to machine one of these plates for the bottom. So the lead screw is going to be held firmly in place within the column, and then the brass nut for the lead screw is going to mount into a block that'll then screw into the column head here. So as I spin my hand wheel, it'll turn my lead screw and advance my column. So the column, like I said, has about 9¼ inches of travel. And so I was able to dial the gibs in pretty well. So I'll do some more adjusting when I get the machine really ready for final assembly, but that's going to work really well for my needs. The column will be recessed down into the machine. So this is at the bottom of the column stroke, and obviously I don't want it higher than the table or higher than the cutter. That's not going to work. So it's going to come down probably maybe 12 inches or so. So the way that I'm going to set the column up in the machine is I want the middle of my column travel where the workpiece will be centered. I want that to be in line with the cutter so that I can have really a full 9¼ inches or 9 inches of cut capacity on the machine. So some parts that I'm going to need to manufacture will be the slide that actually holds onto the workpiece. So the way that the straight line engine works is it's translating linear motion into oscillation and into a linear cut. So the column is stationary, so it's bolted directly to the machine, so it doesn't actually move. There's going to be a slide, so I'm going to machine out of just some mild steel a dovetail joint. So just like my cutter, it'll be really similar, a male and female dovetail joint with gibs that I can adjust, and probably some oil ports where I can keep it well lubricated. So it's going to have a linear slide that is going to be sprung. So there's going to be a spring mounted to the column. So one end mounted to the column, one end mounted to the dovetail slide. So it's going to be pulling the slide in this direction, and then on that slide is going to be a a guide or a rubber or a touch piece. So that touch piece is going to ride along the pattern bars, and that's what's going to create the pattern. So as the column goes up and down, the touch piece rides along the pattern bar, and so that's going to give me my oscillation. So that oscillation is going to translate into the pattern that's being cut. So then on that dovetail, I'm going to create some sort of fixture to hold a vise. And so this machine is going to be used for more than watch style. So it would be doing some decoration on some firearm parts, some jewelry, really anything that I can chuck up in here, I'm going to be experimenting with. So I'm going to have a couple different chuck systems. So I'll have one that is just centering vise. So it'll be one screw that is left-hand thread on one side, right-hand thread on the other. And as I screw it in, it's going to pull both jaws in and center it along the column. The centering and the height aren't really critical on the straight line engine as they are on the Rose engine, because it is a linear cut. So it's really just to be able to place your first cut where you want it along with your pattern bars. So I'll have that kind of chuck. I'm also going to have what's called a pen chuck. And so it holds the pen barrel vertical and has some gradations. So it acts sort of like a dividing head, and I'll be able to phase that pen or whatever cylindrical item that I want to turn in there. So I know exactly how many turns it'll take to get from my first cut to my last cut, and then I can match my pattern bar with that so that my first cut and my last cut phase together. And then I'll probably come up with a universal mounting system where it might just be a piece of aluminum that bolts on that I can super glue. So just use it as like a glue chuck for any objects that might not fit in the vise, might not fit in the pen chuck, just something universal where if I have an item that I want to turn or provide some straight line engine work on, I'll be able to just throw that on there and glue the part to it. So something that a lot of the vintage straight line engines use, they have a series of belts and pulleys that I believe are in place to help with feeding the column head back up. Since I have such a high pitch lead screw, a fast feed lead screw, it's going to make it more difficult to actually feed this head back up in the reverse stroke. So my plan is to use some gas struts mounted to the column head and then mounted to the machine base that are going to help pushing the head back up, so that when I'm feeding it back up, it's less arduous, since I don't really have a mechanical advantage in gearing and I'm feeding up 1 inch per revolution. So it's a really fast feed. That's a pretty good overview of all of the parts that I've ordered. I am keeping a tally of every part that I'm ordering, as well as just the estimated cost of raw materials that I'm working on. And it's a Google Doc right now, and I'll figure out a way to publish it for anybody who might be interested in building a similar machine. My total all-in expected budget, I'm not really working within a whole lot of constraints with it, but I'm planning on the machine really only costing about $1,200 in parts and materials. So obviously machining, fabricating labor, if you're not doing it yourself, is going to really grow that expense exponentially. But if you are capable of doing machining and fabricating work, the plan is to have all these parts listed for you to be able to order them and make a straight line engine if you're so inclined. And having a machine that I built myself, just like my Rose engine, I know every aspect of that machine. So when it comes to maintenance, when it comes to operating the machine or figuring out ways to improve it, to try out new patterns and innovate with it, I know every aspect of that machine. And so I really want to do the same thing with the straight line engine. So having the pair of the Rose engine and the straight line engine together is going to be pretty awesome. I'm going to be able to create some phenomenal dials, some phenomenal jewelry, artwork, engraving, like I mentioned, some firearm engraving. So I'm really excited to have this machine ready to go. I have, like I mentioned, pretty much every part that I think I need to order. So really it's just going to come down to figuring out the time frame of machining, fabricating, and putting this this beast together. Really excited. This is the first video in the series. I don't have a stringent timeline or deadline to get the machine done, so I'll just be kind of releasing videos as I'm getting work done on the machine. But I hope you follow along. I hope you're interested in the guilloche work and really kind of bringing this dying art form back to life along with me. So stay tuned. If you have any questions, feel free to reach out, drop a comment. I'm happy to help you out. Hope you enjoy the video series. I hope you're enjoying the channel that I'm putting together and curating some different aspects of machining and watchmaking together. Yeah, I appreciate it. Let me know if you have any comments. I'm happy to help out. Thanks.